Hi everyone, my name is Mohammed and I am postdoc at Queen's University. Today I'm going to present my work about what should your runtime configuration framework do to help developers. Configuration is actually a mechanism that allows users to change the behavior of software system without touching the source code. For example, in Google Chrome, you can change the font size, you can customize your search engine, etc. However, other software systems tend to have much more configuration options. They have hundreds of options that can be available on just a textual file. For example, MySQL has hundreds of options that are just available on textual file, and that leads to a lot of problems and configuration errors. And in prior study, we found that developers face 22 challenges related to the configuration engineering process. Some of those challenges are inherent challenges, like adding options increase complexity. Other challenges are technical. For example, removing options is risky. We found that people do not remove configuration options because they don't know the impact of each of their configuration options. The traceability between options and code is also challenging. It's not easy to find for a configuration option where it is located or where it is used in the source code. We also found other management related challenges, such as an unclear configuration ownership. There's no clear rules: who should add options, who should remove them, who should change them, etc. In this paper, we are trying to address 13 challenges by proposing 4 principles that a configuration framework should implement. We obtained those 4 principles by a prototyping technique. We interviewed experts. After those interviews, we obtained ideas about what are the typical principles that a configuration framework should implement. Then we developed those ideas and in the prototype, which we presented in the next interview, and we got feedback from another expert, and we got new ideas, and we kept improving our framework, our 4 principles, until getting at the end a framework called config to code that implements our 4 principles. The first principle consists of bringing configuration options metadata inside the source code. We found in our prior study that developers do not consider configuration as code. Therefore, the best practices that are related to the source code are not applied to configuration, such as code review. So we found that people do not review options because they consider options as an external artifact. Therefore, to mitigate this problem, we bring configuration metadata inside the code. For example, if you want to say that username is an option that can be changed by a user, we just add the annotation as config that defines all the metadata related to that option, such as the name, the comment that describe it, the default value or constraint, and where is this option. The second principle consists of automatically generating the configuration file. We found that projects can have multiple configuration mediums for the same project, and that makes the understanding of configuration and the usage of software system more difficult. We also have an inconsistency between configuration files and the source code. Therefore, to avoid this problem, we propose a principle that automatically use the annotations that are inside the code and generate the configuration file. The third principle is to access the configuration file from one provider, one class, and this is the encapsulation problem. And traditionally, developers access options everywhere in the source code, while in this principle, we suggest to access them from one provider class. The last principle consists of validating the quality of an option, such as validating naming convention. Here we say that the name of option is mandatory to respect certain format, and if it doesn't, we show an error during the compilation. This is the error message. For example, here we have a very long name for option, therefore we show an error. We can show just a warning, and when this error is fixed, there is no error or warning. We validate our 4 principles via user study, in which we compared config to code and preferences, the state of the practice framework on Jabref. So Jabref by default use preferences, and we implemented a second version for Jabref that used config to code. 55 participants were involved in our user study. We implemented 10 configuration engineering tasks related to the creation, refactoring, etc. And we validate our 4 principles via 2 research questions. Do the principles increase the correctness, and do the principles reduce the time to accomplish a task? And we found that our framework is able to improve 7 tasks. It doesn't, I mean, there's no case where preferences is better, and we were not able to improve 3 tasks. For the time we were able to improve 5 tasks, we did not improve 3, and preferences were faster in 1 task. Finally, configuration is cause a lot of problems, and we found that developers face 22 challenges in prior studies. In this paper, we proposed 4 principles to improve the configuration frameworks, which we validate via user study, and we found that the 4 principles improve the state of the practice framework preferences. Thank you.